Okay, so here we go. Let me just double check actually the audio settings. Things might go a little bit skewy whilst I do this. I say I've been having real problems with my mic. So let's have a look. Everything should be going through voice meter, which is then going through crisp. Levels. Put that up to about 90, I think. If it can get to 90. Doesn't seem to want to do that. There we go. Okay. Let's make sure voice meters ready. And that's got good levels. Yeah. Okay. The mic itself. Levels. Yeah. So technically you should be able to hear me now. You should be able to see me. Let's have a look. Let's have a look at me looking at me. YouTube. So yeah, apparently I'm live, which is always a good start. See if I can hear myself. Yeah, that's not too bad. And it's not very jittery as well, which is a good start. Okay, let's get started. So just a bit of learning really today. I was working over on Radius. If we look at GitHub, look at the Radius project. And I'm just having a look at a couple of PRs. I find it really easy to learn just by looking at other people's PRs and trying to work out what they've done and whether I would do it that way. So there was update to Terraform execute. Terraform's now been introduced into Radius. Well worth having a look. And just having a look at the file changes for this to enable this within Radius. And this was just an update, right? It's the libraries. So basically just mod updates and check some updates, updating the libraries for the Terraform stuff. Nothing special here. But there was also an update to code, which was unexpected. And there was an update here, right? To look at the state to make sure if it's equal to an empty object, right? Nothing special there. But this was updated actually to use reflect deep equals, which really confused me because why would you need a deep equals for an empty object? So why would this not be the same as this? Because there's nothing in it, right? We check if it's nil. If it's nil, bail out. And if it's equal to an empty object, then bail out. And that just feels a bit weird to me, but I've not used Reflect before. I don't know how. I've just never come across it. For the comparison signs always worked for me, even when I've been doing like API stuff, which I don't know if it's just a great fluke. But one of the things that's not clear is what problem this is trying to solve. Yeah, we understand a deep equals is going into an object, or, you know, that's what it is in JavaScript and other languages, that you basically can go into an object and then into their properties and then into their properties and keep on diving through until eventually you've checked all of the things, right? So let's check it out. Let's have a look. Let's check it out. Oh. So head over to Reflect within the GoLang packages and just have a look at the core functions. And there's three. A copy, which I already like. copy copies the content of the source into the destination until either the destination has been filled or source has been exhausted. It returns a number of elements copied, okay, as an int. So dest and source each must have a kind, slice, or an array, and dest and source must have the same element types. So basically, copy one into the other. And if they're both of obviously the same object type, then it's easy. But we get back an int to let us know how many have been copied, and we assuming that destination is then going to be filled with all the data that's in source. Do you know what? A copy is super useful, and anything that's in a big library like this that's used by quite a few people, it's going to be tried and tested. It's when you got stuff like pointer references that can save you, because you can make sure that you were actually using a copy of that and not actually a pointer to it, even when you're using things like slices, which can be problematic. So as a special case, source can have a kind of string or a type of string, and if the element type of destination is kind, use int. Okay, well, strings is an array of uints, and that means that technically they're both the same kind, but I think I'll have a play with that. And then a deep equals, which is what we're here for. Not reading all that. Too much for me. Let's have a play. Let's have a play. Let's have a play. Let's have a play. Let's have a look. Dev. GoLang. Don't know why my odds were complete now decided not to work. Dev. GoLang. Samples. GPL Taylor. Yeah, let's have a look. Let's make a directory for what we're looking at. Reflect. Don't know why I do a list. It's crazy. You do a list whenever you do anything. It's just instinct. Mod cheese in it. In case anyone's wondering, I've just had carpal tunnel syndrome. Carpal tunnel surgery, and therefore my hands are still not doing what I want them to do. So GitHub. GPL Taylor, let's create a module, let's call it Reflect. Demo. Git. There we go. Right, okay. Honest to God. It's going to be one of those days, is it? Okay. Not Linux, Windows. Honestly, doesn't work. It's going to be one of those days. Da, 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 da. Let's just set up a skeleton, of course. Let's make sure that we get something that at least runs. So there we go. Hello world down in the bottom corner. Great. We are kind of working. Awesome. Da, 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 da. Right. So what we need to do is import this, right? If we da, 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 ba, 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 ba. Config sh go build, go run, test, and then what do we want? We want to be able to import this package, right? So first question is, where is it? So of course we've got Reflect here. Let's see if I can go to the file. Is Reflect part of the common packages? Yes, it is. Okie pokey. There's a lot in there. Let's get this clear. Let's get this clear before you all start giggling. There's a lot in the standard packets libraries. Not everyone can read it and know it all. Okie pokey. Right. Let's no. Go to main. Let's add that to telescope. Go right. Okay. Well, turn the charm. Reflect. Then what you got is you got reflect. In fact, if I just save this and let telescope help me out a little bit. Reflect, import not used. Well, of course. Give me a chance, go. Honestly, it's one of the things I kind of get it, you know, but I don't really need to be told every 5 seconds that my variable isn't being used or this isn't being used. I'm going to get there. And, you know, coming from a C# background and C and VB and all that crap, you don't get that. You don't get this like, oh, you don't have this, you got a warning. Now we see red as really bad. Where in Go you gotta forgive the red and then go down, and as you start adding code, the red goes away. You know, it then fixes itself. But you know that can be problematic. If I can make that a bit bigger for everyone. Yeah. Ooh, I don't want to go too far, otherwise I'm going to go blind. Okay. So how are we going to do this? If we do the MSG1 equals hello, and then see that, look at that, it's terrifying, it's absolutely terrifying, but as Go, you just go, yeah, it's fine, it's okay. And the MSG2 equals world. Reflect dot oh, why are you not working? Telescope, visitor, or whoever you're supposed to be. Maybe I can't use it that way. I wonder if I have to create a new instance of Reflect in order to then use the Reflect object. Because I ain't getting anything. What was it? It was like a deep copy or deep compare. Oh, deep equals. MSG1. And then MSG2. The result equals that format. Let's print it out. If anyone's wondering what the hell I'm doing, I like to play about with something and try and figure out if I can figure out how it works before I then go on to documentation and read about it properly. I just, for me, I like poking it and working out how this works and what does it do. Have I even spelt it correctly, and all them things. And then once I've either got it working great, if I haven't, and I go to the documentation and have a look, and I can then work out where I went wrong. If I just go to the documentation and just type out blindly what they've got, then really it doesn't go in. You know, I come to it next time and I've completely forgotten it. I mean, forgotten it like I've never done it before. So for that reason, it's kind of a waste of time. Where this way, it really does stick in. So number found. I'm still not quite sure what this number's all about. Go away. Set. Then result. So undefined reflect. I think I spelt it wrong, like an idiot, or maybe it needs including. Reflect. Ref. Ref. Okay. That's honestly, that answers a few questions. Yeah, there we go. So deep equals takes any, gets any, or returns a boolean. I swore it said it returned an int. That was a copy. Getting confused between the two. Okay. Delete word. There we go. Right. Okay, let's run it, see what we get. So undefined deep equals. Really? Really? You want to go there? I'm spelling this wrong. Deep equals. Yeah. Do you know what? It's so difficult to learn how to retype. Hello world, none found. That, and of course they're different. So let's. Oh, a macro to build it and run it. So they're the same as you'd expect, right? I mean, this is really primitive because this is just a string, right? And it's called deep equals. The idea is that it's going to look at types and go down the tree. I wonder if I can do something weird. I wonder if I can like concatenate a number, like an ASCII value. I'm sure how to do that. But your obvious one is replace that with an uppercase. That should be false, right? Run quick. Yeah. So, you know, with these being a string, it's just a collection of UTF-8 characters. So the UTF-8 for that and the UTF-8 for that is different. I'm wondering whether there's a go for expert. Create a string saying hello world in GoLang. Here's what happened then. Well, shortcuts went mad. Create a string hello world using UTF-8 cars or runes. Runes? Runes. Da, 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 da. So I wonder if that's going to do what I want. There we go. Oh, using the oct values. Because obviously hello world in runes and then runes converted to a string is just exactly the same thing. Here we go. This is where I think ChatGPT rules. In yes, I could have wrote that. I could have gone through and looked up the octal offset for every string there, and I could have rolled it out. But oh my god, it would have been time consuming. Well, with this, I can just take this bad boy, go into here, let's paste it in, and then let's convert message to string for string export runes. I think it's strings as a cast. It's just string. Where's my macro gone? Where's my macro gone? Hello Vim, where's my macro gone? So different. World. Replace with a W. So that, let's run that. That's saved. Don't be telling me that. Don't be telling me I think I registered it. Because I know what I've done. So it's different. Hello world, number found. So let me check. I've got the runes. Got a collection. Hello world as well. Insert. That's the other negative of comma of ChatGPT. Is I'm sure I didn't say that. I said to create a string saying hello world, and it created me a string of hello world. Oh no, I'm being daft. I thought there was a comma in there. There's not. Okay. Well, that's obviously going to be different. You quitting so quickly. See, yeah, hello world, hello world. Do you know what? Because I'm stupid, I'm going to delete that. Because that's just going to keep on. I see a string, find a string, change the string. It's like, oh my God. Right. So that's cool that it understands that. And this was just a silly demo. But, you know, I could put in, you know, what's the, let's see if I can put something into it that's going to actually change the signature of the string. So there's a couple like new line, carriage returns, ChatGPT. What's it's 12? Oh, daft boy. So let's take that. New line. Let's write that. So let's run. Don't know why that's bailing out so quickly. So false. So it realized that the two strings weren't the same because I've got a new line return at the end of this string, and I've also got it. I haven't got it here. So I think you can do that. Somebody at the door. Hopefully the wife will get it. So let's cancel that. Let's run. Come on, run. Here we go. And now we're true. We are okay. So I like this. You know, it's upholding what you expect it to do. Obviously basic string for string. It's kind of the same thing. I just wanted to play. For me, I would actually start injecting other characters in there, but we're kind of done. So I think the next one is to kind of look at examples now where we've got some real data, right? So if let's get rid of this. What we could do is we could start looking at types, and we can inject a type like person with first name, surname, and then a type with address, and then we could actually create two of them and do a deep equals, then do a copy, then do another deep equals. And that'd be pretty cool. And then make changes to each one and make sure that it hasn't sliced memory pointers into one into the other, which can give you a bad day. So let's have a look. Let's see if there's any good tutorials on this or anything. So reflection, most of the time variable types and functions in Go, pretty straightforward. When you need a type, you define it. You need a variable, you create it, and when you need a function, you make it. But sometimes it can be a little bit more wonky. So finding your types, this kind. So reflect is a type of. Okay, so that's just looking at the whole reflection. I'm not bothered about that. Deep equals. I'm more interested just in the deep equals, if I'm honest with you. Otherwise, you get bogged down with the just sheer size of these libraries. I mean, I know it's been like, what, 10 years, 12 years, but oh my God, there's so much out there. And so much just in the standard library. You could spend your lifetimes going through each one and just learning it. So let's have a look. GoLang, which provides an inbuilt support for implementing a runtime reflection and allows program to manipulate objects and arbitrary types with the help of Reflect package or reflection. The reflect deep equals function in GoLang is used to check whether x and y are deeply equal or not. To access this function, one needs to import the reflect package. Like this, syntax function deep equals parameter blah blah blah. Below illustrates the use of this. So I'm pressing J, but because I'm in this UI, it's not working. Okay. So package main import function main. So create an array of, well, a map of strings, put it in there, create another one, deep equals, print whether map is equal. So it's kind of what I did, right? But I just did it with a basic string. I didn't do it with an array. So I was on point what I was doing. I kind of get it. Go package main import function. What we're doing here, right? Reflect value of source, value of test. and then copy source into destination. Count equals count plus 1. Okay. Anyone who watches this, comment please. Then reflect deep equals. I've got anybody in the chat. Thanks, Felix, for the sound check. That is really useful. Because the sound has been a nightmare for me. So I'm not quite sure why he's doing count plus 1. Maybe when I look into this a bit more, I'll understand what it's doing. But I can copy and paste this and play about with this. So destination is equal to source false. Here's a complete roadmap for beginner developer. Right. So let's have a bit of a play about with this one, because the other one I understood, this one not so much. Can I copy this? Please tell me I can copy it. I really don't want to type it all out. Okay. Already in insert mode. Oh god. Copy. Format buffers. So we can get rid of this one. Just get that. Right. Okay. Let's run it. And of course we get the same output. This is why you don't learn by copying and pasting, right? Copy and paste it and run it, or I've read it and it doesn't give me any more benefit to it. You actually have to poke the bear. You have to go in and try and work out what the hell's going on. And why didn't I get a variable not used for CNT? Right. So is that Go, or is that the Go language, or is that the Go LSP that's doing that? Because there is no value in the count variable here. None whatsoever, as far as I can see. We get it out. We arbitrarily set it to, you know, well, count plus 1. Then we don't actually do anything with it. Okay. So it equals 4. Now, my guess is that because we've got an array of 3 items and we've added 1 onto it for some reason, that's the value of these. So I'm going to just check my assumptions. 1, 2, 3. Still 4. So source and destination. One, two, three. And it's not a key, is it? No, this is just an array. I'm going to say this wouldn't work if this is a key. Seven, okay. 2, 3, 4, 5, 6, and arbitrarily setting it. I'm getting rid of that. It's just confusing me. What do you think I want to do? I want to delete the whole line, honestly. Okay. So let's print out these things. Keep my hands on the home key. SRC. P. Come on, work with me. Clear in Word. Test. And I believe that Go should be able to just output them because it's just a nice array. Awesome sources. So what have we got? We've got a source, which is just an array of values, and then we've got a destination. And all we're doing here is, I think we're just completely and utterly wiping them out. So as we copy destination to source, sorry, source to destination, don't like the order. Copy into the destination from the source. I'm gonna have to get that into my head. Copy into the destination from the source. Because if we look at the bottom, destination here, this is the puppy here. It's got the update. So it's clear that source has gone into destination. So copy into the destination values from the source. If we have a look now at destination, let's reduce the size of destination because I wonder what it's doing with the array size. Oh, what? What? Work with me here. Work with me. Come on, come on. Help me. You're supposed to be helping me. That's what you're supposed to be doing. But you're not. Because you ain't going into normal mode. Oh. You know, these tools and these things are supposed to help us. But when you've got fingers that don't work for a little bit, it is kind of hard. Okay, what am I up to? I was looking at destination to see if source and destination, whether it will pop out destination with more stuff. Should do, right? Or does it just copy down? Hmm, copies down. So because the destination isn't as big as source, it's only going to copy down the values that are it's got available to it within its array size. So because the array size of source is bigger than the array size of destination, it isn't going to wipe out destination, create a new array that's the right size, and then pop it in. It's just going to do it. So copy isn't really copy. You've got to be careful because, and there probably will be some argument to this. I would have thought. So copies the copies the content of source into destination. We've already read this. Been filled into source. It returns a number of elements copied. Okay. Number of elements copied, source and destination. So the number of things copied is interesting. So what we got, 1, 2, 3, 4, 5, 6. Once I cut officialize. Okay. Source, and then what have we got? For a deep equals, we got false. And the number of items copied was 5. So we got 5 out of the 6. And it's obvious, right? Because the destination isn't big enough. But that's something, that's a real gotcha. If you didn't know, it's obvious now I know. And I kind of get it because it needs to be memory efficient. And also, we're passing in dest there. And this value of then going to be value of is going to be a pointer, isn't it? Value returns a new value initialized in the concrete value stored in the interface I, and then returns 0 value. Okay. Am I being thick? Probably. What I'm thinking is, are we actually manipulating dest? As your case, source can have the same kind string if the element types of dest is kind. So that's something I need to look into a bit more, especially with this type parameter not set. And also my thinking about copy, because we're copying source and destination, but of course that's that's a value type, not a pointer. So how the hell is it actually changing it when inside the copy? Getcha. I getcha. That's what you're doing. Okay. Right, so very, very, very popular, powerful. Let's see if there's anything else worth having a look at. Come on, my shortcuts don't work. What's the main? This viewer. Let's have a look if we've got anything else. I think this one was pretty good. You look at GoLang's Reflect Deep Equals. Who is this by? Let's see. Garg. When I was pretty new to GoLang, I was developing a GoLang client for one of our platform services as GoGet. I discovered a few things which may prove useful for beginners as well as people who are well versed with GoLang. Read on. So I've been using Go for about 10 years or so, but on and off with different projects, working on things like C# and then even Java, unfortunately. And then, of course, Go. They've always been like dive onto Go, then dive onto C# and work with a team. So I'm really surprised that I've got this far and didn't know about this. Maybe I've just been damn lucky or damn ignorant, one of the two. The problem statement. Broadly, this is with respect to data types in GoLang. So I wanted to compare two objects. Well, we know a tool for that. especially two primitives in GoLang. Two interfaces are said to be of equal quality if and only if they have the same dynamic type and their values are equal. Dynamic type. Is that where like an int can be compared to a rune, and which a rune can be compared to a string, and even though these type objects have got different properties within them, they can therefore still be considered equal. Dynamic type of a variable is important when handling interface values. Dynamic types are defined as following. Static type or just of a variable is a type defined by its declaration. Variables of interface types can also have a distinct dynamic type, which is the actual type of the value stored in the variable at runtime. Dynamic types may vary during execution, but is always assignable to a static type of an interface variable of non-interface types, and the dynamic type is always the static type. So, you know, some value, anything, is a 2. Oh, what's a 2? More than likely an int, right? Then some value interface, some value equals foo, right? Dynamic. I'm not a fan. Reminds me of PHP. You know, if you know what it is, you're in a strongly typed language, define it. In fact, I'm a big fan of even defining things, you know, like, let's see if I can do this. Type int of, you know, case ID, so that when I want to use something now, I can just refer to it as case ID. And yay, that's going to be an int in the background, but case ID means more to the business that I'm in, right? The company that I work for. If I was to say case ID, everybody in that business would understand what case ID meant. Therefore, I'm not going to use this random int value. But then to do something like this, some value is anything, I just can't figure out why you would want to do that. Well, of course I can. You know, when you don't know what the type is that's going to come back and it's loose, you know, you want to do that. I just think it's a bad idea. Right, so dynamic typing. So the values are equal. For instance, let's keep up one. Let's take up an example. Oh, I think I know where this is going. Let them cook, as the Primogen would say. Let's take up one example, understand the deeper problem. So, horrible formatting. There we go. That's the sucker. That's the puppy. Interface X. Now X is now going to be an integer. Did I say that the right way around? Yeah. Interface X. Now X is going to be an integer. Now we can go over its type. Oh, I see where you're going. Type int, and we know we've got an int, so I'm thinking we should be running this code, right? Does it? When the above code runs, the output is, yeah, number. Okay, so nothing weird there. This is expected as X is, of course, of type interface, and the underlying dynamic type is X. I wonder if this is kind of stuff that was fixed using generics, right? What's the problem then? Well, let's stay with copy, compare. I think I know where this is going. So I had to compare one of the key value pairs in the JSON, which one of the stored variables as per business user case. Let's see it. So we've got a type, school, struct, int, interface, ID, interface, and name string. Right, so here's where our dynamic typing exists, because no one knows what our primary key is, right? Who on God's green earth would know what our primary key type is? Now we've got main, X is a new school. I'm going to just randomly pass in an int here. Check it in. And name is the name of school, and convert that to the byte types as a Marshall. And then if we had a problem, bail, but we should be all right. Then unmarshal the bytes. Y. So passing in the pointer. And now what we're doing is we're doing a deep reflection to see, so reflect deep equals X and Y, both the same. Otherwise print that they're different. And then print out X is that and Y is that, and they're both the same right when they're printed out. So let's have a look at this code and let's see if I can work out where he's going with this. Let's copy the types first. So type, let's take that, let's go here, insert B, and let's go into the main, and let's take out this body here. Please, if you're doing stuff online, please have a copy, please format it well. Oh, Jason, where is it? Cottage on Jason. Okay, what's undefined? OS. I don't know why it didn't auto fill these in. We go notebooks. Okay, let's go. So X and Y are different. Interesting. So the value of X is 1, GoLang public school. The value of X, Y. Oh, well, they're different anyway, aren't they? Oh, no, idiot. It's just the value between the brackets that's printed out. So 1, GoLang public school. So I was thinking, well, of course they're different because you've got X and Y, but no, X and Y. So X and Y are different. Gotta be you, hasn't it? Gotta be. Why? Oh, da. Commercial. Is this a serialization to JSON problem? Like a float becomes an int because the value within it is just a 1 and not a 1.0782, or a 3, not a 3.145869728.7. Let's read on. Because I could go through this and binary compare them and then work out the diff. That'd be very cool. If deep equals to could do, you know, when you're running unit tests, if deep equals could actually do an output diff comparison, that would be super awesome. You know, for debugging purposes, that you could just output it and say, look, this is different and this is why. So what have we got? When I run the above code, a little unexpected. Yeah, a little unexpected little thing that just goes for beginners in GoLang, or people who've been doing it for ages but just never bothered learning this bit. But surprisingly, it was the same for other experienced devs. Go run main, the value of one is that, they're different, but when I ran the above code by changing the code from ID to output was as expected. Go for the same. So, but when I run the above code by changing school ID to 1.2, okay, that was ID. There you go. End. Replace. Oh no, let's insert. Let's do 3.145. Done. Both X and Y are the same. Now I don't know whether this is a serialization problem or an issue with the Marshall code itself, or just a typical day in the life of Jason. I wonder if we go in, let's see what we've got. Let it cook, let it cook. They're both the same. Oh, nice. Require debug and understand what was actually happening. So yeah. So gotta squint at this. So let's focus on interface. Type int as one. Int interface. Float. Yeah, I'm a bit slow today. So yeah, we were an int, and now the y instead is a float 64. Jeez. Bit high. GoLang types. We got 32 and 64. Languages like C# have just got like thousands of them, and it's really weird to keep in Go and realize that no, just a couple, just a smidgy. So yeah, 32 and 64. Okay. So we pass in one and we get a 64 float. Here's the memory. Here's your memory. Go on. It's okay. You don't need it. You don't need it. It's CPU that costs us now, not memory. We're all in the cloud, right? So after debugging at every step, you know what was happening? We observed one thing. So if you see in the fig, we can see that dynamic type of Y after unmarshalling got to change to a float from an int. So whenever we do a deep reflect equals, it gave false. Whenever we did deep equals, it gave false as the underlying type dynamic type of both X and Y were different. I think I know what it means. So what do we do? Use types. After rummaging through Stack Overflow, and on Google, I was redirected to GoLang's documentation. Surprise. The documentation of unmarshal function. Let's have a look at you in a sec. Unmarshalling float 64. Our business user case was such that we could not ignore the underlying data type. We tried hacks like converting the dynamic type to int. If it was an undefined type, it's float 64 and its whole number. This was working fine, but was causing some problems when the interfaces were becoming more complex. Use types. Solution: colonial form. Colonial form is representation such that every object has a unique representation, with colonization being the process through which a representation is put into its colonial form. Thus, the equality of two objects can easily be tested for its equality by using a colonial form. So is that like the abstract syntax tree? Pop it out, put it in, put it all in its types, put the values in, check the data types, check the syntax tree, check the values, bim bang bosh, we've got a comparison. We thought of writing a wrapper. What? I love that. Love that. You know, this isn't working right. We'll write our own. Why is it not working? Because if the people haven't managed to get it to work, the open source community and the collection of millions of developers couldn't work. What makes us think that we can take this out and put it into a library and we can get it to work? I just love that. Love that. Love that. Let's see what happens. If the original reflect deep equals returns true, then we can directly return true. Yeah, because it's fine. But if it equals false, we go, are you sure? You know, open source community who wrote deep equals, who are like amazing, genius, 10x developers. I'm just going to check your work. I'm just going to check your homework. Returns false. We then testing the equality of the colonial form. The problem was int was getting converted to float. Yeah, we know that after unmarshalling. Or was it? You know, he's saying that, but of course, JSON doesn't have types. Unless you use the schema. And maybe that's what you need. You need a contractor schema that tells you how these things unmarshal. It's called types. Anyway, the problem was that it was getting converted float. Yeah, so we converted both objects to the colonial form by first marshalling. Yeah, I know that. Them, and then comparing their unmarshaled forms. So marshal, unmarshaled interface. Not quite sure what this graph is telling me. B goes into bytes, then into the interface. Conversion of the two interfaces to the colonial form. So what we're doing here, got our own deep equals. One and two in an interface type, because we all need that, don't we? Let's not use generics. Returns true, of course, because that's what deep equals does, you know. And then deep equals 1 and 2, bailout. Now, if it all goes pear-shaped, let's add a little bit more work onto this. Let's make it a little bit slower, and let's make it do a little bit more work. So var x interface bytes a unmarshal and get the bytes. Then JSON unmarshal the bytes into that, which could be anything, and ignore the results. Get it to the bytes, and then do it again from the bytes to this. And then obviously do the same for the second. Unmarshal. Then JSON unmarshal the bytes again into this new variable using pointer address, or the address. And then we check. Otherwise we return false. Well, you could just return that, right? Suppose we want to bail out for this if, but I just don't like it. Anyway, I would just return that. But people love their if statements. So let's use this in wrapper. So we do this, do that, same thing. Deep equals is going to use our deep equals, which is now this function here. And we get the right value. So you may come across this problem in computer science where two things need to be compared and convert them to the colonial form. So did I have an example of that? No, that was dynamic types, which is obvious. Did he have anything on colonial form? I think he did, didn't he? I just didn't click on it at the time. Oh. Right. No one wants to sit here listening to me read that. A colonial form representation that every object has unique presentation. It's a schema, right? And by doing the interface type to the byte types and back to the interface types, we somehow make that int back to an int. And because the bytes represent the type, well, the bytes represent the character sets. I need to look into that a bit deeper as to why that works. Anyway, I didn't want to get into other people's implementations. I actually just wanted to get into deep equals, and I've kind of done that, right? We did that. We understand what it is. I think an hour and 13 is probably long enough for everybody. I normally want to keep it less than an hour. The copy is going to obviously copy the value into the destination from the source. I'm interested to know whether if I do a copy, because the copy is probably going to do something similar to the bytes, whether if I just did a copy before I did a deep equals, that it fixes this weird problem of the serialization. Anyway, I kind of get it. I understand it now. Do a bit playing about with it, but that is a little bit of Go, a little bit of playing, a little bit of live coding. So if you liked it, same story. This is the Gizzard.